Hello, class. So I'm going to walk you through lab 3.2, help you with the computations, the ones we're doing in Excel, and then the ones that we're doing in JASP, because we're going to do an independent samples t-test to compute the data to see if there was a significant difference in our unrelated and our related anagram solution times. So hopefully by now I've emailed you the CSV file. And again, like in the previous lab 2.2 that I helped you with, this data set that I'm using is from a previous semester because I don't want to give you the answers because I want you to do the work yourself, but I do want to show you how to get your answers. So your information, your data set should look different than mine. Don't freak out when you open your CSV or Excel file because my data set that I'm using for this video is from a previous semester that I taught this course. Also, I'm going to send out the Excel and the CSV file because you're doing the first part of the work and making your figure one in Excel, and then you're doing the t-test part in JASP, and you'll need the CSV for that. So I will have sent you both by the time you're watching this video. Let me share my screen. So first, let's look at the module so you can remember what we're talking about. So lab 3.2 here. You can see this. All right, so we are looking at the effect of category set on solution times for anagram puzzles. So you had your 4 participants, you gave 2 of them a related word set, you gave 2 of them an unrelated word set, you recorded how many seconds it took each of them to solve that anagram, or at the end of 4 minutes, you told them what the answer was. And so you scroll through here, this is the stuff we read through last time. The data analysis and write-up. Here we are for lab 3.2. So you're going to compute the mean solution time for anagrams 1 through 6 for the 2 conditions separately. Prepare a single graph showing any changes in the solution times over successive problems for each of the 2 conditions. Then determine whether there was a statistically significant difference between the mean solution times on the list for unorganized and organized or related conditions by applying your independent samples t-test. And then it must be an APA format when you write it up. Use your template from lab 1, use your template from lab 2. I went and put very detailed feedback into everybody's lab 2.2. So if you did not receive 100%, download the graded submission and you'll be able to see exactly what I said and where and why. So by the end of this class, you would be able to write a 100% accurate APA data sheet or data lab report, which is pretty cool. Then there's a sample here if you want to look at the sample lab report. The introduction has to restate the purpose of the study, which is that stuff that's above there, but use your own words. 1, 2 paragraphs max. The method section, so remember that your introduction section is your first level 1 heading, but it's not the word introduction. A lot of you did that. It's the title. So whatever the title of your paper is, that's what your very first level 1 heading is, and it's not the word introduction. The method is your second level 1 heading, and it has to contain these 3 level 2 headings underneath it. In participants, you should have how many, the mean, standard deviation, and age range, and the gender breakdown, how many males, how many females. I'm not going to show you how to do that in this video because I showed you how to do it in the last video. So either play around in JASP and see if you can figure it out yourself, or look back at the last video. Your second level 2 heading in the method section is materials. Describe the 2 lists of anagrams and use your specific lists as an example. So when you say for the first time an unrelated list, tell me what 6 words you used. And for your related list, your organized list, tell me which 6 words you used there. Procedure, describe the procedure of the data collection, how it was recorded. Then your results section, that's a level 1 heading. Describe any changes that are evident from the graph. Refer to the graph that I'm going to show you how to make in a second as figure 1, but also put it at the very end. So do not put it right there in the middle of your results section. Talk about it in your results or state what it says. Talk about it in your discussion section especially, but do not put the figure until after your reference page. Also describe the results of the t-test. Tell me what you did, what the analysis was, and what you found. So for example, right here. We analyze the mean number of drinks in an independent samples t-test with this group versus this group as your grouping variable. Over a 2-day period, participants drank significantly fewer drinks in the experimental group, or not significantly, depending on how you need to word it for what your results say. And this is what your numbers need to look like. So you need to have them in statistics formula format. Your T of whatever equals whatever. Here's your p-score here. Obviously the words are different, but this is what the stats need to look like in APA format. Your P should be in italics, and you should have a space on each side of the equal sign. I'm not sure why that didn't show up there, but as far as the parentheses, capital M, capital SD for standard deviation, after the comma, after the M, just 3 digits after the period, the decimal, right? You need to make it look just like this, but make the words make sense for whatever results you got. Then the discussion section, your last level 1 heading for this paper, accept your results. Answer the following questions, not in a bulleted list, but craft your discussion in such a way to smoothly address each of these questions in a flowing narrative. Answer each question or related questions in a separate paragraph. So you see there are 3 bullet points here, which means you need at least 3 paragraphs minimum for this discussion section, maybe more depending on what you're talking about. What change is in the solution times appeared over the 6 successive anagrams for the organized list? What about for the unrelated list? Were the unrelated and organized list groups approximately equal in solution times for each anagram at the outset of the experiment? So for the first couple of words, what about at the end? What about the last few words? Did you observe any differences in the expected direction? So tell us what you thought, what you expected to find, and then what did we find? Lastly, is it conceivable that the formation of a category set might actually impede rather than facilitate solution time? How? Could you suggest an experimental design to test the hypothesis that the anagram solution might be impeded with the formation of a category set? So then you have to have references. So you have to have a minimum, these plus 2 references. So these 3 plus 2, so at least 5. These are the 3 you're using in your method section or wherever you're talking about previous research we were looking at because of these guys, however you want to word it. But in your discussion section, you also need to cite 2 others. I think we say it here. Note that you should find at least 2 or 3 additional references, journal articles, peer-reviewed journal articles, at least 2 to support your claims to talk about in the discussion section. So those are all the instructions. Now let me close this and show you how we're doing it. So I'm going to share my Excel file. Screen sharing this file. And you see here, I've taken everyone's data. This is the Excel version. Have age as my first column, then gender. The list type is either OR for organized or UN for unrelated. And then times 1, 2, 3, 4, 5, and 6, and then the mean time, which y'all didn't give me, but I just did a formula. And so for this participant number 1, their mean time of trials 1 through 6 was 29.16, and then all the way through. So that's what your document looks like. So what we're first going to do in Excel is a little bit of data organization. I need all of my organized and unrelated rows together. So I need them organized first and then unrelated. So what I'm going to do for that is I'm going to highlight my entire data set. Okay. And then I'm going to go to data, sort, and I'm going to sort by list type because that's this category right here. And it's A to Z, so it'll just put them alphabetically together. And now you can see all of my organized rows are together and all of my unrelated rows are together. So make sure you do that first so that the data is the way we need it to do what we're doing next. Now we want to collapse all of the organized rows into their averages. So for time 1, what's the average? For time 2, what's the average? For time 3, what's the average? 4, 5, and 6 for all of the organized. And then the same for all of the unrelated. So what we're going to do for that is we're going to create a separate little table over here. So I'm going to write organized and unrelated. And then I'm going to have for trials 1, 2, 2, 3, 4, 5, and 6. So what I'm going to do is a formula here to get all of these organized times for 1 into one average. So this entire column here, I need averaged out. So what I'm going to do is I'm going to put equals average, open parentheses, and now I'm going to get all of time 1 for organized. So I'm going to highlight it all, and I'm going to stop where organized stops. I'm going to let go, close parentheses, and then I'm going to click off of it. Look at that, 37.62. And then I'm going to do the same thing for unrelated. I'm going to do equals average, open parentheses. Now I'm going to come down here to unrelated and highlight all of these data sets. Let go, close parentheses, click off somewhere, 26.38. So you can do that for every one of them if you want to do it the hard way, even though that's already an easy way. So I can just ask Excel to copy this formula all the way across. So you see how I have a little white plus sign here? If I move it to this bottom right corner, see how it turns to a black cross? I'm just going to drag that all the way over for 2 through 6 and then let go. And it's going to copy that formula, but it's going to do it for each of these different sections because Excel's really smart. And I'm going to do the same thing for my unrelated list. Turns to a black cross, drag it over, bam. That just saved you 20 minutes. Maybe not that long. But now I have all of my averages. So now that I have that, I want to turn this into my figure 1. So I need to make it a graph. So I'm going to highlight all of what I just made. And I'm going to come up here to insert. I just want a regular 2D line graph. So depending on which version of Excel, it might be in a different place or look like a different thing, but insert 2D line graph. So I'm going to click on that. I'm going to move it over here so I can see it. Look at this beautiful line graph. So what are we seeing? So my organized is my blue line, and this is the seconds that it took them to solve, the participants to solve the anagram. And this is trials or words 1, 2, 3, 4, 5, and 6. So it looks like for my organized, for my blue, we started around 40, and it does look like people got faster. You can see they got faster, a little slower, faster, a little slower, faster. But it kind of does look like on the continuum, people are moving in the quicker direction. For my unrelated, it looks like people go in the opposite direction. Takes longer. Then they suddenly get faster and then it takes longer again. So that's not really clear. I'm not really sure what that's saying to me, but it's a nice visual to see. Here's how people did on the average for trials 1 through 6 for their first word through their 6th word. So this is my figure, but I need to clean it up a little bit. So I need some, what am I saying? Labels for the APA format to be correct. I don't need this chart title here. I'm going to delete that because you put the chart title above your chart in APA format. So I'm going to click on my whole chart somehow. Okay. And then again, it might be different depending on which Word or Excel version that you have. What I need to do is I need to insert, or I need to go to chart layout, access titles, and then we're going to do a horizontal and a vertical. But for yours, it might look like mine where you have add chart element over here and then access titles. And then first I'll do the horizontal at the bottom here. And I want that to say trial because that's what these are, right? These are trials 1 through 6. And then I want to add my chart element, access title, primary vertical. And I want that one to be solution time, parentheses, in seconds, close parentheses, because we always want to say when there are like seconds involved or some time, whatever involved, we want to explain what that is, right? We want people to know when they look at that. what that means. So now I have my cool little figure one, and I'm going to right click on it. I'm going to copy it, and then I'm going to go to Word. I'm opening a blank document, but hopefully yours isn't blank. Hopefully you have already started your Lab 3.2 sheet, or you have your template from your last one. Okay, I'm going to paste, and you need to give it its APA title up here, the way it looks in your APA manual, but at the bottom it needs a caption. So my caption is going to be Tier 1. Under that, I'm going to put mean solution time in seconds as a function of list type, and then say what those list types are. We have organized versus unrelated, and trial. And then the trials were 1, 3, or 6, close parentheses, period. That would be a beautiful caption. So, I mean, I guess spell unrelated, right? So if your figure caption looks just like that, that would be completely fine, because that's what we did. And then make sure you talk about this in your discussion section, right? What figure 1.1 or figure 1 means. All right, I'm going to stop share again. And now I'm going to share JASP with you because you need to do an independent samples t-test. So let's compute some numbers. We're done with Excel, so you're done with the Excel file. So now you need your CSV file somewhere. I'm going to open on my computer, browse, lab 3.1. Okay, so here's everything. You can look at these variable types up here, right? We want the ruler for everything, right? Obviously, time, mean time, those are ruler variables, but so is H. I don't know what I did there. I didn't mean to do that. Watch that back. I need to change age to my scale, but gender and list type, those are ordinal variables, which you learned about in this week's lecture. How handy is that? And so I have all of my columns with the correct variable type. So what I'm going to do is I can see how many participants I have. I see all this data here. I'm going to come up here to t-test because I want to find out if the mean time is different as a function of list type through my independent samples t-test. So t-test, independent samples t-test. So over here for the first variable, what should I put? Any guesses? The dependent variable is, pause the video, think about it. That's right, mean time. And then the grouping variable is, pause the video, think about it. That's right, list type. Good job, team. Okay, let's see what we got. And again, my data is different than yours. Don't freak out. Let's see what you got. Here's your t-score. Here's your degrees of freedom. And here's your p-value. My p-value looks like it's significant. So 0.03 is smaller than 0.05, which means I found a statistically significant difference between my mean times. I don't know if you did or not. What does your data tell you? If it did, it did. If it didn't, there might be a reason that it didn't. So I'm going to change my p-value. How can I do that? Am I manipulating the data? It's not magic, it's science, y'all. So if you can remember, well, first let me give you Cohen's d. All you have to do to get Cohen's d is effect size, and then make sure Cohen's d is highlighted here. Here's my Cohen's d. It's negative, but it's 0.4. So if you remember, there's like mild, moderate, there's different levels of Cohen's d, and if the effect size was mild or a moderate effect size or a great effect size. So 0.45, 0.5, right? That's in the middle. So that's a moderate effect size. So it looks like I have significance and it looks like there's a moderate effect size. And if you don't have significance, but you have a moderate effect size and you're confused by that, let's see what we can do about that. You see here, this alternative hypothesis section, it says group 1 is equal to group 2. Well, that's not what we did here because we had a directional hypothesis. We were saying that they weren't equal. We were saying that the um, I'm sorry, that the organized list would be quicker, that people would solve it quicker than the unorganized list. So we had a directional hypothesis. So since we had a directional hypothesis, we need to change it here to group 1 was less than group 2, because that's what we said in our hypothesis. Well, look at this, my numbers changed. I got the same t-score, the same degrees of freedom, the same Cohen's d. Look at my p-value, it's down to 0.1. It's like really, really significant now, right? And why is that? How did that change? If you can remember back to stats and you think about the standard distribution, right, bell curve, and you think about the t-crit area, if we're saying there's no direction, it's not a directional hypothesis, the t-crit area is split up between both of the tails, which means it's smaller to have significance. But if we have a directional hypothesis, that means all of the t-crit area, the critical area for the t-score to be significant, is in the left side or the right side of the tail. So for ours, that means the p-score, the t-score could be smaller, but it still be a more significant number because it's directional. So anytime you can have a directional hypothesis, that's much better because it gives you more power and more room to play with to find significance. So remember that you need your descriptives too. So how do we get that? Oh, we have to click this button that says descriptives. Look, now I have my organized mean, standard deviation, and my unorganized mean and standard deviation. So play with this and see if you can figure out how to find your gender numbers, mean, standard deviation. And if you can't figure it out by playing with it, then you can go back and look at Lab 2.2's video to figure out how to do that comp. But let me stop sharing. That's it. Now you have all of the data that you need to be able to write up your Lab 3.2 data file. I hope that makes sense. And if it doesn't, feel free to email me with any questions that you have.